Welcome back to Crazy Gamers Games and electronics enthusiast. Wait till you see what we have here. We have a special guest, Kid Crazy.
Hi again.
Hey, Kid Crazy's back, and now we're gonna take a look at some of the electronics he's learning, and he's learning these snap circuits, which are circuits in disguise. They have basically these snap together electronics that have their snaps and they have electronics in them. And there's tons of projects to look at. We'll take a look inside the box here. As soon as we open the box. And we're going to take a look at what's inside. And as you can see here, there are many different electronics. Let's see, we just point some of these things out. We got disco ball, battery holder, some motors, some kind of melody IC, some connectors, some different LEDs, some switches. Looks like we got a fan there. Who knows what that does? Ooh, a compass. So basically, this is just an electronics learning kit. We have a few of these that we're going to be going through. We're going to pick a random box every day and just, it's summertime and the kids are out of school, but the learning doesn't have to end. So we're going to get something set up here, show you how to build one of these, and explain how that circuit works. And Kid Crazy is going to join me. Pause for 1 minute. Okay, so we got it open here, and we're gonna look through the instruction manual here and show you some basics of what's going on. How do you like these snap circuits, Kid Crazy?
They're awesome.
Yeah, we do a couple different ones every day, don't we?
Yep.
This one covers magnetics, electronics, and gears. So this has got like a whole STEM action going on here. And basically the book, you got all the components it comes with. It comes with these snap wires, just battery holders, base grids, LEDs, compass, illusion cards, small gear, large gear, and we got a whole page over here of more stuff. And then it goes through basically how to use the snap circuits, and it's pretty simple. You snap them together, and you'll see in a minute how they snap together. It gives you basically a layout of where to put everything, and then more on how to use the individual components like the illusion mirrors and how to connect them in three-dimensional. How to hook up the gears with different LEDs, the disco ball, the fiber optic tree, and then this is about the different parts. You have a reed switch, a slide and press switch, the connectors and jumpers, a battery holder. You have a sound module, lamp, motors, some LEDs. What color LEDs do we have in there?
We have color 2, blink red and blue.
Okay, we got a blink and that sounds interesting. And then it basically gives you an introduction to electricity. I have a basics electronics series if you want to know more about that. But it's basically, shows you how different things have to flow a certain way with polarity. And then it has a very large page that has a lot of information on the do's and don'ts of building circuits. And, very specific, you don't short out batteries and things like that. Always make sure there's some kind of resistance in the flow, in the way that the current circuit flows, so you don't short out a battery. If there's no resistance, it shorts out. And a wire is a small resistance, but not enough. So, and then it gives you some troubleshooting information on how to troubleshoot your circuit. It's recommended you have an adult help you with that. Kid Crazy has started to build his on his own. I just check them over to make sure they're correctly, and then of course we play with them because they're fun. So we're going to go ahead and we're going to do project 1 here, and you can see here it calls for the battery pack. So why don't you get out the battery pack, Kid Crazy? Okay. Okay, and then we'll use one of the smaller bases on this one. Turn that on without blowing
Can I build it?
Yeah, you're gonna build it here. So KidCrazy is gonna build this. Let's just get out all the pieces so they see. We're gonna need a 3-snap wire.
I see what we need.
Well, I'm just letting them know.
I'm just saying. They keep on saying what we
Okay, yeah, we got that. We're gonna need that slide switch. And it looks like we're gonna need that color LED. So let's take a look here. We got this color LED. This is color 2. We've done a few snap circuits. I haven't seen color 2 yet. See the first color one. So it's got this is a diode basically. It's got a plus and a minus side. You want to hook the plus to the plus. Current won't flow in the opposite direction. It'll block it, as all diodes do. And just for reference, all these diodes that come with these things, they have built-in resistors. If you're going to connect diodes that are not snap circuits, you need to put a resistor in series with it. So go ahead, come down here and build it. Okay, so he's got the battery pack on there.
The 3 connector.
And it tells you in what order to place things down. So he had to place down the battery first, and then he had to place down that 3, and then we got the switch.
Now, remember, don't turn it on until you check over it.
Yeah, I want to make sure when we're putting the batteries in, the switch is in the off position. Okay, so what I'm going to do is I'm going to turn down these lights because I want you to be able to see what we have here.
Yeah.
Okay.
Oh, it's very dim.
Okay, well, that's what we want to know. So go ahead and you turn on that switch there, KidCrazy.
Bam.
Boom, we got a light. It's red. It looks like a red light. Oh, wait, nope. It's changing colors.
There's an RBG.
No, actually, it is a color changing LED, but this one is just 2 leads, and it changes colors by using a microprocessor, like a microcontroller, on inside one of these LEDs. In my basic electronics videos, I'll be going into detail showing pictures of how tiny this LED is. So let us put this fiber optic tree on there, because that's what it tells us to do. It's down there, KidCrazy.
Here's the tree.
So we're going to show you with this fiber optic tree, then we're going to talk about what's happening.
See the actual tree.
Yeah, you see this? Yeah, it's a cool little tree. So we'll just put this on there,
Keep the lights dim.
and boom, a little fiber optic tree. See if
It's
we can
better
get that
than
in there.
the
Yeah, this one looks good. I like the tree. We had some other ones that was supposed to look like a firework. It wasn't as cool as the tree. You see how it changes colors? It's purple there. And then, we can turn it off. And when we turn it back on, it's going to start red. The way the microcontroller starts off, it always starts red. So,
Let's see.
and then we also, oh yes, we have an egg we can put on there. Let's put the egg on there and see.
Don't need it.
Yeah, I would need a blue egg anyways. And if you look, it's hard to see, but if you can see, now it's all washed out. You can actually see on the top of the egg the 3 different colors. Like right now it's showing a red circle, and now it's showing a red circle. It had a green circle, and there's a little bit of a blue circle. Yeah, that's really hard. It's not coming up over the camera. Yeah, that's all right. They're just seeing the light.
Sorry, guys.
So let's put the fiber optic tree back on there, because that was the best to see. And now let us talk about what's going on here.
Now it looks like.
Let's turn.
Now with the
Let's turn some light back on, and we'll talk about what's going on here. Okay, so we have 3 AA batteries at 1.5 volts. That's giving us 4.5 volts because they're all in series. We have a switch going across from the positive to a wire snap. This is a 3-snap. That's basically just a straight wire with snaps that goes to the positive of this LED, this color changing LED, and then it comes right back into the negative. So it flows this way. Now, if we turn it off, we stop the flow of electricity. And if we happen to put this diode in backwards, it wouldn't light at all. But I don't recommend that on the color changing LEDs, because they don't like going backwards. It tends to fry their microcontrollers, and they like to sink a lot of current. These are PTC fused with a resettable fuse, but I just don't want a chance ruining
Hey,
it.
why don't we check the voltage?
You want to check the voltage
Yeah.
drops?
I got that fancy voltage thing.
Okay, let's, oh, you want to check it that way. So we're going to use some snaps. We're going to check the voltage. So let us get out a meter here. I'm getting a lot of... It's alright, I'm trying to fix the light. It was working earlier in a video.
I think it's a back. Blame it on the back.
Oh, it's the lighting system I have.
Magnets can wreck electronics.
Okay, I'm going to pause here and we're going to come right back.
Take the tree off.
Okay, we got it set up here so you can see the voltage. So where do you want to check the voltage at?
Let's
You wanna
say
see-
the battery. Let's
you-
show the viewers the battery.
So you want to see, well, we don't need those to check the battery voltage. So we're just going to leave that on there so we can see. So we're going to clip the negative to the negative and the positive to the positive. And you can see that the batteries are slightly lower. They're not putting out the 4.5 volts. They're putting out 3.8. So these batteries are a little dying. They're rechargeable. So they are a little less voltage in general, but they still power the circuit.
Yep.
So now we have, what was that? That's 3.8 volts we had there. Now let us go ahead and hook up the leads to the diode, and that's the negative on that side.
Battery.
No, leave that on. We're not going to measure the current. We're going to measure the voltage drop. So we're going to clip on some jumper wires across
I don't wanna measure the
we're
current.
going to measure the current across the,
I have a fun tip too.
okay, that's just, it's not on. And as you can see, it somehow got turned off.
Me?
Okay. So we can see we are dropping the full amount of voltage onto the diode. Like I said before, there is a resistor in there. So KidCrazy wants to check the current.
Yeah.
So we are going to show you how to check the current. So we'll go ahead and turn the circuit off for this. We will turn off this meter, and we will bring in the meter we will use for current.
Now this is how you check a current. I like certain colors I like.
Okay, so
You need some out there.
no, we're good.
Make sure you don't blow your meter.
It's not going to blow the meter. It's on the 10 amp setting. Go ahead and flip the switch.
Bam.
So basically, we are doing 20 millivolts.
Up to the
So we're going to find out exactly what that is. Because I'm going to change the setting of the meter to 200 millivolts.
now.
So 16.9, it's dropping a little bit. So 14 millivolts. So that's how much current it's drawing, 12 now. 12 milliamps, I'm sorry, not millivolts. So basically you want these LEDs to run around 20. As you can see, as the colors change, the current changes. So when the blue is lit, bring that in so you can see that. As it has the purple uses multiple colors, so the current goes up to about 24 to 25 milliamps. And then white uses 3 colors, and then as it switches to one color, it drops down to 16 because it's only lighting one of the LEDs. The same with this, it's only lighting the green, so we're only drawing 14. And then now only the blue, which will drop down to about 12. And then as we go into white, which is all 3, well, green and red now, so 22. And then we're going to go into white, which is going to come up, and it's going to go up. Purple, 2 colors. And hopefully white is the next.
Yeah.
Here we go. And then we're going to go back up to the 25 milliamps.
Wait.
So.
Don't ever connect these ends together. You might start a fire.
Yes, that is possible.
Yeah.
Don't short out batteries.
Yeah, don't
So let's turn that off and let's not touch while we're measuring current, okay?
No.
Yeah, don't mess with the leads when you're measuring current, especially if you're a child. So let's turn this off. Now let us set this back up to originally, and we'll see if we can guess what resistor is in the hand me that calculator, please. So we know the voltage is 3.8 volts. 3.8 volts. And if we divide that by the current, which was 0.025. So it's got about 150 ohm resistor in there. Probably 180 ohm resistor inside this diode. But we can check that resistance and see if we get a reading on it. Let's bring in this one, and we'll see if we can get a reading on that resistor that's in there. Yeah, doesn't look like we can get a reading on it. Oh, wait. Now we're just reading the backflow across that diode, so we can't tell what resistor's in there. But with the math and Ohm's law, it shows it's probably 180 ohm resistor. So that's it for project 1 in this Snap Circuits kit. So I hope you enjoyed that. Stay tuned for more Snap Circuit electronics, other electronics, Warhammer related things, tabletop gaming related things. I'm the Crazy Gamer. You are?
A little crazy, right?
KidCrazy.
Keep on.
Okay. For Crazy Gamers Games, have a great day.
Bye.